Here we are at problem 4a from our target 2. We're asked to use the distributive property to pretty much simplify this out. Now, before we actually dive into this, I'd like to do like a little bit of a side problem here, just to kind of get us acclimated to what's actually happening here for problem 4a. If we think about if we had a half of, let's say, 6, a half of 6, well, we should know that a half of 6 comes out to be 3. So again, a half of 6 comes out to be 3. Now, what would happen though if instead of a half we said maybe like 3/7 of, in fact, we'll change this number up too. We'll make him 3/7 of 5. See, in this situation, it was a lot easier to say, oh, a half of 6 we know is 3. But when you come across something more like this, where it's 3/7 of 5, it's not so easy and apparent. So what do you really do then in this situation, where you can't just identify that value? Well, we can say that 3/7 is still there. He's not going away. It's being multiplied by this 5, or 3/7 of 5. We can rewrite this 5 as 5 divided by 1. Because again, 5 divided by 1 is still just 5. So we haven't really changed this at all. We're just changing the way he's looking is all. Now, if we want to go ahead and simplify this down and kind of get an answer much like this one that we just saw, what we would end up doing is multiplying our numerators together and then multiplying our denominators together. So when we do that, we end up with 3 times 5 to give us 15. And then on the bottom, we have our 7 times our 1. So again, 7 times 1, on the bottom we would end up with just 7. So this would be incredibly hard to come up with if we were just given our original. But that is really the math that's happening behind the scenes here. You would be multiplying the numerator with the numerator and the denominator with the denominator. We can even prove that that's actually happening right here with this earlier one. So we know that a half of 6 is 3. That's no new surprise, but let's again actually show that and prove it. So pretty much just doing what we did right here. If we had a half of 6, well, we can write 6. We can rewrite that as 6 over 1, because again, 6 divided by 1 is still just 6. So we're not changing this guy at all, we're just changing the way he's looking, that's all. Then, again, just like before, we're going to multiply our numerator with our numerator and our denominator with our denominator. So 1 times 6 gives us 6. And on the bottom, we have that 2 times 1. Now we can go ahead and do our simplifying. So 6 divided by 2 just gives us 3. So again, that's just a nice little verification that what we're doing over here truly is in fact working. Now let's use that to help us then with problem 4a. Well, we have a fraction outside, 3/5. And we are multiplying it by this 2x plus 10. And we are multiplying it by this 2x plus 10. Well, we can rewrite that 2x as 2x over 1. Likewise, we can rewrite this 10 as 10 over 1. Because 2x divided by 1 is still just 2x. This 10 divided by 1 is still just 10. So again, we're not changing this at all. We're just changing the way it's looking. And now we can go ahead and use that then to distribute or do our multiplying part that we were seeing over here and over here. So distributing our items, we end up with 3 times 2x. That gives us 6x. 3 times our 10, that gives us 30. Now again, when we're distributing our tops, we're also distributing our bottoms and multiplying those as well. So our 5 times our 1 gives us 5. Our 5 times our 1 also gives us 5. Simplifying things down, this we can actually just leave alone. That's 6 over 5x. He's fine. However, our 30 over 5, we can break that down into just 6. 30 divided by 5 just comes out to be 6. So this would be our distributed version. Now the other method, kind of a little shortcut, would be pretty much just noticing that this is a fraction. It's being multiplied by this, which is, it is technically a fraction, but at the same time, there's no real denominators that are making it, you know, where you actually have to multiply the bottoms with the bottoms. And as a result, you can just multiply the tops, giving us 3 times 2x is 6x. 3 times 10 is 30. And then do that all under one value 5. And notice we can go ahead and simplify this down, giving us 6x over 5, and then 30 over 5 as well. Which again, we end up with still the exact same thing. Nothing's changed. This is just a different approach to look at it if you wanted to multiply in using that distributive property. Again, really because the denominator here is just 1. So this is the slightly shorter way. However, I do like this approach too because this is really like showing you the math behind the scenes and what's going on. So this is kind of the behind the scenes. The whys and what's happening. But either one, as long as you're good and comfortable with using it and know what's happening, then I'm happy. But I don't really care which one you decide to choose. Again, though, that is problem 4A from our target 2.